Assalamu alaikum. In this video, we'll derive lensmaker's formula and a lens equation. Here, lensmaker's formula is helpful to design any kind of lens of a desired focal length. To do so, I consider one thin lens. Let me show this to you. Here I consider a thin lens which has got two refracting surface. This one refracting surface. This is the another refracting surface of this lens. Usually we call this kind of lens as a biconvex lens. First, a convex lens is one whose refracting surface is bulged out. Okay. If it has got two refracting surfaces, then it is referred as biconvex lens. Bi stands for two. Now, the center, the geometric center of this lens is represented by letter P, which stands for pole. Here P stands for pole, which is the center of a given lens. And the line which passes through this pole is referred as principal axis. We call this line as principal axis. This line connects the pole, principal focus, and the center of curvature. Clear? Now, what is the center of curvature? As this lens has got two refracting surface. Now, let me show this to you here separately. Suppose this is one lens. This lens has got two curved surface. This one curved surface, this another curved surface. If I just continue the first curved surface, as per our diagram. If I continue this one, then we find that it forms a sphere. So this clearly shows that the lens is a part of the sphere, isn't it? If there is a sphere, definitely we will have a center. We call the center of this sphere, of which the lens is a part, as a center of a curvature. Okay, I named this as C1 because it is the center of curvature of the first refracting surface. Okay, and I do the same thing with the second refracting surface. I just continue this. If I do so, it also forms a sphere. It also forms a sphere, and this sphere also have a center. We call this the center of curvature of a second sphere, of which the lens is a part. Okay, or of which the second refracting surface is a part. Clear? This is how the diagram is drawn. Now, if the center of curvature is connected with the pole, is the pole, which is the center of a given lens. By doing so, we get the radius. Here it is the radius of curvature R2, and the line which connects the pole to the center of curvature C1 gives us radius of curvature of this particular circle. Okay, so like this we have a radius of curvature for surface 1. So with here letter R1, and the radius of curvature of second refracting surface is somewhere here. So here R1 and R2 or radii of a curvature of these two refracting surfaces. Okay. Now next I take one point object. Here one point object is taken and is represented by letter O. This is a point object. Then our ray of light incident from this object which falls on the refracting surface of 1. If we consider that only this refracting surface is present, then refraction will take place from the first surface. Then we'll get the image at this particular point. I name this image as I dash. Okay, this happens only when the first surface is present. No, we get a I dash in the absence of a second refracting surface. But here we find that before the light form image at I dash, refraction takes place from the second surface. So it bends and a form image at the I at point I, the image is formed. Okay, this is the real image and this one is the fake image. Understand? Now we know the distance between object and the lens, or correctly speaking, the distance between object and the pole of the lens is taken as U. This is the object lens, and here the length or the distance between lens and the image is taken as V. This is the image distance, and here we have got one more image, isn't it? What is that? It's nothing but I dash, fake image. That I take the distance between lens and I dash as V dash. Yeah. So these things are known. We have several parameters there. Now we'll go ahead. Now I'm going to get the lens maker's formula. For that I start with the general equation. The general equation for refraction. The general equation for refraction from a spherical surface. So the general equation for refraction through from is going to write the through a spherical surface, a single spherical surface. Here, this general equation is written in this manner. What is that? Now we take this equation directly from the previous topic. Now, look carefully how it is written. Here, one thing I forgot to mention. The lens is made up of a material whose refracting surface is N2, and it is placed in a medium whose refracting surface is N1. So both the sides we have that medium whose refracting surface is N1. Okay. So here at the beginning light travels from medium N1 to medium N2. Then after refraction light travels from N2 to N1. Here several times I have used the term refraction. What is this? Refraction is nothing but bending of light when it travels from one medium to another medium. So here you can see when light has entered from medium of refractant index N1 to a medium of refractant index N2, it bends. You can see this bending of light is called as refraction. Understand? Okay. Now I am going to write this general equation for refraction through a spherical surface. Now here N2 divided by V minus N1 divided by U equals to N2 minus N1 upon R. This is the general equation. I take it as equation number 1. Okay. Now when light travels from N1 to N2, this general equation can be written as when light travels from a medium of refractant index N1 to a medium of refractant index N2. In such case, equation number 1, this equation is written as. Okay, now before going ahead, let me tell you that here I consider the presence of only one refracting surface. I take only first refracting surface. If I consider in that way, so let me show this to here. Suppose I take only one refracting surface. Here, this is the principal axis. Okay, and here we have the incident ray from point to O. Then here, if I consider that only one refracting surface is present, then refraction will take place from here. Okay, then we form image at this particular point. Okay, and according to the diagram, this point is chosen as I dash. Clear? For only one, for the presence of only one refracting surface, refraction takes place in this manner and image is formed at I dash. So here, what is the distance? Here, orbit distance is U and image distance is taken as V dash. So I am going to make certain changes to this. And here, light travels from N1 to N2. So other things will kept as such. N2 will be placed as such. Whereas here, V is replaced with the V dash and U is kept as such without any change. Okay, whereas here we talk about the first refracting surface. The radius of curvature that we get due to this surface is nothing but R1. So R is replaced with the R1. Now this is what are the changes I am going to make here. So M2 is kept as such. In the place of V, I will take a V dash. Okay, it is the distance between the lens and this image I dash, and N1 is kept here as such. In the place of U, I take U. Clear? Then N2 minus N1. It is written as such without any change. But in the place of R, I will write R1. I take this equation as equation number 2. This is taken as equation number 2. Okay. Now, let's see what happens when light travels from, when the light reaches the surface 2. Second case, when light travels from medium of refractive index N2 to N1. Or it is better if I mention here as at a refracting surface 2. Here also I will do the same thing. Here I will write at a refracting surface 1, not 2, it is 1. 1. Okay. Now see what are the changes I am going to make. Look at this carefully. Here I consider the presence of only one refracting surface. Here this time I take this refracting surface, this second refracting surface, and I draw a line. I call this line as principal axis. Fine. Now this time from the diagram, now I take these two rays which are present on the other side. Got it? Here refraction takes place from this surface and it forms a image at I, and we have one more image here. Which is at the point I dash. Got it? Here, listen to this carefully. Here I dash acts as a virtual object for surface 2. The I dash acts as a virtual object for a surface 2. Remember this. This is very important. Okay. So if it is so, from the diagram, the distance between I and the lens is a V, and the distance between I dash and the lens is a V dash. Okay. This is what you get. Now, as I told you, this acts as the virtual object for the surface 2. So it won't be wrong if I write that here U is taken as V dash. No, in the place of U I write a V dash, and in the place of V it is kept as such. Okay. And the second thing, here light travels from a medium of refractive index N2 to a medium of refractive index N1. So N1 is replaced with N2 and N2 is replaced with N1. Okay. With all these changes, the equation number 1 can be written as, in the place of N2 I write N1. Now, as I have shown here, divided by, in the place of V, what I'll do? I'll take this as such. Then in the place of N1 I'll write N2. Then in the place of U, it has to be replaced with V dash, because here I dash acts as virtual object for the surface 2 is equal to, in the place of N2 I write N1, in the place of N1 I write N2 divided by R. Here R is taken as R1. It's taken as it is taken as R2, not R1, because we have only second surface. So R is taken as R2 here. So by doing so, we get the third equation. This is named as equation number 3. Now, before I proceed, I am going to make certain changes to equation number 3. What are they? Let's see what I'll do. N1 upon V minus N2 upon V dash is equal to, I'll say, what I'll do, I'll rearrange it. First I'll take a n2 minus n2 plus n1. By doing so, it is not going to make any difference. Okay, and here this can be written as n 1 upon v minus n2 upon v dash equals to if I take a minus out, I'll get n2 minus n1 upon r2. Now you multiply minus n with each term. What do you get? You get the previous equation. Minus with n2. Get minus n2. Minus with minus becomes plus. Plus n1. Okay, this is the modification we have done. What is the reason for doing this? I have done this to get an equation whose right hand side term is similar to the right hand side term of equation number 2. You can see here n2 minus 1, n2 minus n1. Here also we have n2 minus n1. Okay. For this modification to do so, I have done this modification. It is taken as equation number 4. Now I will add equation number 2 and 4. Equation number 2 is added with the equation number 4. Let's see what happened if we add these two. I'll start with equation number 2. n2 upon v dash minus n1 upon u here plus n1 upon v minus n2 upon v dash. Then this side, what do you get? You get this n2 minus n1 upon r1. Here plus and minus gives us minus. Okay, just I add, isn't it? Here I have minus n that I take here. Then n2 minus n1 written within bracket divided by r2. Well, this is what I get. Here also I take these two terms within bracket. Now the similar terms n2 upon v dash plus this minus, these two cancel. The next step, what do you get? Here I am going to reduce one step. I will take the common terms outside. Fine. After rearranging it, first I take a plus term, then minus term. n1 is taken out. Then 1 by v minus 1 by u. Clear? Equal to sign. Then what is common here? n2 minus n1 is common. It is taken out. And what remains? Now is only what? 1 upon r1 minus 1 upon r2. This is what I get here. Understand? Now one more thing I do. I take a n1 to this side. So 1 upon v minus 1 upon u becomes equal to n2 minus n1 upon n1. Written within bracket. Then remaining thing is taken as such, 1 upon r1 minus 1 upon r2. This is taken as equation number 5. Clear? Now, before I go ahead, I am going to make a certain changes to this. Here, I consider that the object is placed at infinite distance from the lens. So here, u is the object distance. It is taken as infinity. And it is also found that when the object is placed at infinity, it forms image at f, at the focus. And we know the distance between the focus and the lens is represented as focal length. So V is taken as F. I hope you have understood. Now I am going to substitute these things in equation number 5. Here I will substitute. So what I will get if I substitute this one here? I will get the place of V I write F, 1 upon F minus 1 upon infinity equals to n2 minus n1 upon n1 multiplied with 1 upon r1 minus 1 upon r2. This can be done as, here we know 1 upon infinity is, what is 1 upon infinity? 1 upon infinity is 0. Now if you divide something with infinity, what you get is nothing but 0. Okay, it's because it is a large quantity. Whenever a large quantity is present in denominator, the result obtained is a very small value. So this disappears and becomes 0. So in the next step, I'll get only 1 upon F. To save the space, I'm writing here n2 minus n1 upon n1 multiplied with the 1 upon r1 minus 1 upon r2. This is taken as equation number 6. This is equation number 6, and this equation is nothing but lens maker's formula. Here equation number 6 is referred as lens maker's formula. Now I will derive lens equation with the help of lens maker's formula. Okay, let's do it. Before I get the lens equation, I'll do some modification to equation number 6, which represents lens maker's formula. What I'll do, see, here this equation is written as 1 upon F equals to n2 minus n1 upon n1 multiplied with 1 upon r1 minus 1 upon r2. This is equation number 6. Am I right? Let's rewritten as such. Now here I am going to split this particular part. What I'll do, n2 is divided by n1 minus n1 divided by n1. 1 upon r1 minus 1 upon r2. It is taken as such. The next here n1 divided by n1 is, this 2 gets divided, we get 1. Yeah. So 1 upon f is taken as n2 divided by n1 minus 1. This is what a new equation I obtained. Okay, 1 upon r1 minus 1 upon r2. So this can be taken as a lens maker's formula. Here, if you want, I can make some other changes as well. Now suppose I consider that the lens is placed in air, then if the lens is placed in air, for air the refractive index is taken as 1. So certain changes I'll make. I'll take n1 as 1 and the n2 will be taken as n. Okay, by substituting these things here in the above equation, see what I get? I get this 1 upon f equals to n divided by 1 minus 1 multiplied with 1 upon r1 minus 1 upon r2. This can be written as 1 upon f equals to n minus 1. N divided by 1 is n. Here 1 is, forgot to mention 1 here. So n minus 1 multiplied with 1 upon R1 minus 1 upon R2. Understand? Now I am going to box this equation. Fine. This is the final equation which represents the lens maker's formula. Now I will get a lens equation. Lens equation can be obtained if we compare equation number 5 and equation number 6. If you compare 5 and 6, the lens equation. Lens equation is obtained by comparing. Equation number 5 and 6. If you compare these two equations, you will find that the terms present on the right hand side of equation number 5 is similar to the terms present on equation number 6. So these two are taken out and we write this 1 upon f here is equal to this term 1 upon v minus 1 upon u. This is what we obtain at the end, and we call this relation, this formula or this equation which relates u, v and f for a given lens as lens equation. Okay, then I take this as equation number 7, this equation number 8. Okay, here lens equation gives the relation among the object distance, image distance and focal length of a given lens, whereas lens maker's formula tells us what should be the radius of curvature of a given lens to get a desired focal length. Okay, here n is the refractive index of the medium of which the lens is made of. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your question in the comment section. Thanks for watching.